Today we are going to study that what is energy and what are its sources and what type of energy sources we use in our buildings. So first of all, what is energy? So the simplest definition that we can get of energy is it's the ability to do work. So energy is actually how things change and how do they move. It takes energy to cook food, to drive to school, to light a bulb. So these are the different types of energies: mechanical energy, thermal energy, nuclear energy, and so on. But basically we have two types of energy. One is renewable and the other one is non-renewable energy. So let's talk about the non-renewable energy. It is those type of sources which we cannot replenish, and they are formed when the prehistoric plants and animals died and they were gradually buried by the layers of soil and rock. So these are the four basic types of non-renewable energy: fossil fuels or oil which is actually generated by the fossil fuels. Then we have coal, nuclear energy, and natural gas. This is the kind of fuel that was created varied depending upon the conditions, like what was the material at that time. Was it organic material of the plants or was it the decay material of animals, and how long it was buried for, and what was the temperature and pressure which created those fossil fuels. So let's study a bit in detail about these types of non-renewable energy. First is nuclear power. It's the actually we do a nuclear procedure which is called nuclear fission, which produces the energy generating steam, and that steam actually spins the turbines attached or placed in the nuclear power system, and by spinning of those turbines electricity is produced. Next is coal. So most of the power plants actually use coal-fired steam turbine to generate power, but there are very few which actually convert the coal to gas before using it directly in the turbines. Then we have natural gas. Natural gas is the same gas that we use in our houses. Sometimes we use natural gas combustion alone, or sometimes we use it as a part of furnace or boiler system, and hence it spins the turbines to create energy. And the last one is petroleum or oil. So petroleum can also be burnt to produce combustion gases or to produce steam to power turbines. Okay, next is the renewable energy. It is the energy which is collected from the renewable sources. So any source of energy is considered to be a renewable if it is coming out of a natural source, or it can be easily replenished whenever we wish to. So examples: solar energy, sun will always be there for our planet. Biomass energy, plants are always going to be there. Then we have wind energy, geothermal energy. This is the energy that we get in form of lava and steam from the earth. And then we have hydropower energy, which actually we get from water. So what are the different types of renewable energy? First is geothermal energy. It is the heat from within the earth which we use for heating water into steam, and that steam actually spin the turbines to generate power. Then we have solar energy. This is the energy that we get from sun. We actually capture it into photovoltaic solar cells, which further heat the fluids to produce either steam or for driving turbines, or to generate electricity directly within a small building. Then we have biomass. Biomass is the one that we derive from plants and animal waste. Materials are burnt directly and used as other fuels to power turbines or internal combustion generators. Next is wind. So wherever there is a huge wind loads, we actually construct giant pinwheels there. Those giant pinwheels spins because of the wind forces, Turbines capture energy from the wind for conversion into electricity. And then the last one we have is hydropower. Hydropower is the one that we get from dams or any kind of setups, huge water setup, power turbines using the flowing water. Now let's talk about in detail what is solar energy and how do we use in our day-to-day buildings, because this is the type of energy that is very commonly used even among small residential buildings. So the term solar energy that we use in our houses is basically it's the method that we use to collect the light, and then we directly turn that light into a useful form of energy. And the technologies that we use to gain the solar energy are passive solar gain, solar thermal, that is specifically for the heating purpose, for heating water, not for generating electricity. Then we have concentrated solar power, that is typically for generating electricity, and the solar photovoltaics cells, which is also meant for generating electricity. First of all, we should talk about the passive solar gain. So this is a form of energy that we usually take for granted, but it is in an architect's hand to design the building in such a way that the building benefits from the passive solar gain as much as possible. Because designing a building according to the passive solar gain is going to contribute a significant amount of energy demands within a well-designed building, whether it comes for a heating season or a cooling season. So what happens is that sunlight enters a building through a window and warm the inside, and sometimes we provide windows in such a way that sunlight does not enter the building through the window and the inside of the building remains cool. So a very thoughtful design of passive solar gain within our buildings, it's going to add a very little to the cost of the building, because already we have to provide the windows. So by just placing thoughtfully those windows, we can still gain the maximum of the passive solar energy, and at the same time the building cost will not increase drastically. So how do we do that? We orientate the house in a way that more rooms are facing towards south direction. We are going to provide larger windows on the south side and smaller windows on the north side. We can use building materials in our buildings which are used to store heat, and they are going to add to the thermal mass of the building. Majorly, we use passive solar energy for the thermal gain. That's why these points are all about how we can use the passive solar energy to gain the heat within the building. And this thing, laying out housing development so that the buildings do not overshadow each other, it comes when we are designing the urban space so that houses are not placed close enough that they are overshadowing each other. Even though there are such examples which we can easily find in our surroundings in which there is not enough space, and especially in the walled city, and the houses are actually overshadowing each other and there is no solar energy, no sunlight coming into the houses. So see, this is the south side. We have provided larger windows over here so that the winter sun can get inside the building, but these large windows on the south side, they are not going to allow the summer sun to get inside the building. See the direction of the summer sun. And here on the north side we have smaller rooms. So see what kind of internal functions we have used within a building. So we have faced the living room, which is towards the south side, and we have placed the utility room, which does not require much of a sunlight, or a smaller room towards the north side. Here's another elaborated example of the passive solar gain. So winter sun can easily get inside the building, and the summer sun is actually we have used overhangs or shades maybe so that the summer sun does not get inside the building. We have increased the thermal mass of the building by using the insulated walls and roofs. We have provided a skylight here. We have actually reduced the number of openings on the non-equator facing wall here. so that the summer sun especially does not get inside the building. And for shading purpose, we have provided the foliage, landscaping. So whenever we are designing buildings for the passive solar gain, we have to take into account that this should not be overheating in summer season, because if we are just considering the winter season, we are going to provide too much glass, so that too much use of glass is going to overheat the building during summer seasons. So to prevent that, we use overhang, eaves, shades, and bright soleil that can provide shade in summer months when the sun is high in the sky. So it still let the light to come inside the building, but there is less heat. If we have designed a building which is highly optimized passive solar design, that means that it can cater up to 40% of the space heating load of a property. So you must be wondering, what is a bright soleil? So bright soleil literally means sunbreaker. Okay, so what is bright soleil? Let me show you. So bright soleil, they look like this, these wooden panels. They are small vertical shades. They can also be called louvers, and you change the direction of these shades according to the sun direction and according to the amount of sunlight that you wish that it enters your internal space. So you see, in this building, these bright soleil have different orientation, different direction for different parts of the building, depending upon the usage of each occupant. So the advantages of passive solar design is that it is going to cost you zero extra cost, and it will require no maintenance. They will be everlasting as long as the building will last. They will be there. Plus, a careful aesthetical design is going to add to the beauty, the overall beauty of the building. Now let's talk about the active solar design. So in active solar design, we usually have mirrors installed at the rooftop like this. These mirrors reflect and then concentrate the sunlight to these receivers. These receivers then are going to convert the sunlight into the solar energy and finally convert it into heat energy. Then we have usually a generator is attached to these solar panels, which is then used to produce electricity from the heat energy produced by the sun. So the first technique that we are going to use with the solar energy is the solar thermal. This is basically a solar thermal panel like this. It has a number of coils attached to it. It is usually a black surface. This black surface is going to absorb the light, and it will heat up and transfer the heat into a working fluid, which will be filled in these coils. Now this working fluid is going to move the heat to a place where it is useful. This is the solar controller, and we usually heat water with the solar thermal technique. This is the hot water cylinder, and from here it can be either attached to a boiler or directly to the sanitary fittings. It can be attached to the boiler here because in mega projects like swimming pool or hotels or hospitals, etc., where we have to boil a large quantity of water, then this system is going to preheat the water, say to 50 degrees or maybe 60 degrees, and when that already preheated water is going to enter the boiler here, it will take less time to reach up till 100 degrees at the boiling level of the water. So it is useful in that case. Then another technique that we use is concentrated solar power. So the technique is that if we are going to concentrate the sunlight by the mirrors, this sunlight is going to create a very high temperature. Then this light is focused onto a central point with a carrier fluid such as oil, which will be flowing through it. It is just like the kind of a fluid which was flowing over here in solar thermal. Now this oil is going to be heated up to 400 degrees Celsius, and the temperature will be so high that it will be hot enough to heat the water or maybe make high pressure steam out of it to drive a turbine and then eventually generate electricity. The drawback of concentrated solar power is that it is only going to work where there is a direct sunshine, and the mirrors that are attached here, they are actually held on a support that they can follow the sun direction, so that as the sun moves along throughout the day, the mirrors are going to follow the sun. All of this is going to add to the complexity of the technique, and hence the cost will eventually rise. Because of that, they are only used in the areas where there is more clear sky days and this climate is very sunny, just like UAE or Africa, etc. The last that we commonly use in our houses is solar photovoltaics. PV is a short form for photovoltaics. So what is the strategy here? That we use cells like these to convert sunlight into electricity, and then there is an inverter attached to these cells that converts the DC power into AC, because the electricity which is produced by using the photovoltaic cells, it will be a direct current DC, and we do not use DC power in our buildings, therefore we have to convert that DC power into AC, which is the alternating current. So here's a picture showing that how does it work. So this is the basic photovoltaic system which we install at the top of our houses, like this. This is photovoltaic PV flat panel collector. It is going to convert the sunlight into electricity, which will be our direct current electricity. Then here we will install an inverter which will be converting the DC electricity into AC. Then from here we have a fuse box to which this electricity is going to benefit us in certain ways. Number one, it can actually directly generate different appliances within that house, for example a TV or maybe a light bulb, or the same house can use a backup storage battery to use the electricity generated at night, because there will be no electricity production at night because of no sunshine. And if we are generating a huge amount of electricity which is excessive for our own use, we can even sell it to the government. For that we have an export meter here. So this export meter tells us that how much electricity from here is going to the network grid, to the government actually, so that they can pay us for that. And there's another import meter here, just in case if we are using government electricity for our house in addition to the photovoltaic generated electricity. So we buy from the grid and we can also sell back to the grid. So a very famous example for this solar photovoltaics is Tesla Powerwall. It is actually a home battery designed to store energy from solar or the grid, and so you can use it any time of the day you wish to, at night or during an outage if there is any. So it is very compact, it is affordable, and it is very simple to install. That's why it's becoming very popular these days. Advantages of solar photovoltaics is that it can directly convert sunlight to electricity. It requires very little maintenance, and the lifespan of PV cells is from 30 to 70 years at least. And disadvantages are that it has a very high initial cost. Then it is weather dependent, that if there is no sunshine during the day, it's not going to work. If you are producing excessive solar energy, then which is more than the use of your house, then it is going to be either wasted, or you can also store it, but the storage for solar energy is expensive. That's all regarding the energy and its different sources.